So for this next part, problem numbers 11 through 20, we talked in class about describing the end behavior of each function. So the two I did in class, I'll recap what we talked about in class. First thing I do is identify the degree of the polynomial, and we're only dealing with polynomials here, by the way. So identifying that this, number 11, we have a function that has a degree of 4, polynomial function degree 4, and the leading coefficient is positive, so the graph opens up on both sides. And if you want to use words to describe this, as x goes to the right, so as x goes to the right, y goes up, and as x goes to the left, y also goes up. So we have a left and right, and then we have an up and down. That describes the end behavior. So the way we write that using mathematical notation would be, we write as x approaches infinity, that's x going right. Y goes up, that means that y approaches positive infinity. And then for the other part, when x goes to the left, we say that as x approaches negative infinity, comma, y goes up, so we write that as y approaches positive infinity. And this is the way we write it. We write it using this notation here. The words that I wrote down here in red, that's the kind of thing that you maybe want to be thinking about as you try to figure out what the end behavior is, or as you describe the end behavior. So the next one we did in class was this one. We have a negative leading coefficient, a third degree polynomial, so the graph goes down from left to right. And as we describe the end behavior, we notice that as x goes to the right, y goes down. So we write that as x approaches infinity, y approaches negative infinity. So x approaching positive infinity means x goes to the right. And then we notice that as x goes to the left, meaning as x approaches negative infinity, y goes up. So we say that y approaches positive infinity. So I already wrote out most of what we have to write out here for each of the problem numbers 13 through 20. So if we look at number 13, we see a parabola that opens down. So as x goes to the right, y goes down. So y goes to negative infinity. As x goes to the left, y goes down. And so that means that as x approaches negative infinity, y approaches negative infinity as well. So for number 14, we see as x goes to the right, y goes up. X goes to the left, y goes down. And so y approaches positive infinity as x approaches positive, and then y goes to negative infinity as x approaches negative infinity.